What's up, YouTubers? Dr. B here with another micro vid. And in this micro vid, I wanted to address two things. First, that quiz 4, question 6, that deals with PO2. Regardless of what you answered, you're going to get credit for that one. That was the question itself is accurate and good and fine, but some of the information is brought to my attention. Some of the information on one of the charts in the notes was inaccurate. And so I'm going to bring up that right now and share my screen. I'm going to bring this up. And so this is the slide that was brought to my attention that shows some conflicting information from what you were told by me, even in the audio of this. And so this has been corrected in the notes. I've taken down the old notes and re-uploaded the new notes. And really the only difference is that right here, where we have the arterial PO2 right there. I'm going to actually do that in red so you all can see it. This right here, this arterial PO2, that actually should be lower than 100, right? So it should be, and I actually have right around 90. And I have I think I have this in the notes, right around 90. I can't draw a 9, sorry. The computer's vertical. Right around 90 millimeters of mercury. Okay, so not only right there in the arterial PO2, but then I would also obviously change this one as well. So we're going to change this one down here, this PO2 right there, which it's the same thing. It's just as, doing it on both sides of that. That is also around 90 millimeters of mercury. And then down here, this PO2 right there, which is still arterial PO2, that is around 90 millimeters of mercury. Okay, and so this has been changed. I've changed this on the new notes. So I want you to understand though why it's 90, right? So when we have alveolar PO2 and we've got I'm going to draw right here an alveolus, right? We've got our alveolus right there. And we have our, let's say our blood, pulmonary capillary coming in, right? So we're going to have a pulmonary capillary coming in. So blood is in this pulmonary capillary and blood flow is moving this way, okay? As it's coming into that pulmonary capillary, it's actually deoxygenated, right? It's venous blood, okay? As it goes through that capillary, which is really close to that alveolus, it becomes oxygenated blood. How does it do that? Well, we've got our fresh Louisville air right here. Our air, which has oxygen in it, is going to move into here, and those oxygen molecules, we'll draw them in purple right here, those oxygen molecules are going to diffuse into the blood and therefore oxygenate the blood. Now, under normal circumstances, that blood, that pulmonary capillary blood, becomes 100% saturated with oxygen, meaning the PO2, the partial pressure of oxygen in the blood, is going to equal the partial pressure of oxygen that is in the alveoli, which is around 100, right? So in some textbooks, you'll see even 104 millimeters of mercury. So it's, but in the example that we give in the notes, it's about 100 millimeters mercury. When we're looking at the arterial, okay, so we're looking at the arterial. So if we were to continue this blood vessel, let me zoom out here, continue this blood vessel down all the way over here. When we look at this arterial PO2 of oxygen, it's not 100, okay? It's not 100, and I just said it's going to be around 90 millimeters of mercury. It's going to be less than the alveolar PO2. And the reason being for that decrease is because, and this is once again in the notes, we've talked about this, is because we have right to left shunts. Okay, normal right to left shunts. What are those? Those are the bronchial circulation and the pleural circulation, right? That means right to left shunts are when you get venous blood mixing with oxygenated blood, and so it's going to decrease the total oxygenation of the blood, right? When you have unoxygenated mixing with oxygenated, it's going to decrease it. The other contribution to that decrease in the partial pressure of oxygen that we see in the arterial system is due to VQ mismatches, right? So if we have a VQ mismatch, meaning that maybe we have a space that is it's perfused but not ventilated, right? So if we've got, let's draw that out. So what does it look like if it's perfused but not ventilated? Well, here's our alveoli right there. And here's the blood that's moving the pulmonary capillary that's going right next to it, right? Say we don't have any air. Say air is blocked right here, right? There's no fresh air getting into that alveoli. Well, what do we have? If there's no fresh air getting to that alveoli, then we have venous blood coming in, and guess what? Venous blood is leaving. Okay, so it's not oxygenated, and that venous blood will mix with all the other, hopefully, oxygenated blood, thereby decreasing the overall oxygenation of the blood a little bit. And so that's what we see with this slide, and that's what the slide was supposed to, part of what it was supposed to depict. So make sure that you, in your notes, if you printed out the notes, just go back to this slide, X out 100 and put 90. Okay, X out 100 right here, put 90, and 100 right here and put 90. Okay, that's in the audio of the lecture recording actually say about 90 or 95. And if you go 2 or 3 slides above this, and I have included in there a chart that has, I think at the bottom it says a slide taken from Dr. Strummel's notes. In that chart or that table, it has arterial PO2. Well, let's just go up real quick. Here we go. It has right here arterial PO2 right there. See, 90. Okay. So arterial PO2 is 90 and alveolar PO2 is 100. So now both of those match. Sorry for any confusion that caused. And like I said, once again, I am going to give credit for any or for everybody to, here, I'll go back to this, for everyone on quiz 4, question 6, because that was one of the questions that dealt with that specific concept that had an answer choice that you might have gotten wrong if you had followed what the actual chart was, or not the chart, but the picture was, where it had arterial PO2 as 100 millimeters of mercury. So once again, long story short, to sum up, remember that arterial PO2, that's the partial pressure of oxygen in the arterial system, is always going to be less than the partial pressure of oxygen in the alveoli, okay? And that's due to right to left shunts and VQ mismatches. I hope this was helpful. Make sure that you listen to this video again if you didn't catch everything. It's really important that you understand that going forward for the exams, for the final, for any TBLs, for any future iterations or examinations that we have on this. So I hope this was helpful. Let me know if you still have lingering questions. And as always, stay cool, stay in school, don't do drugs.